Welcome to this tutorial. Today I'm going to tackle a question under tachometric surveying where the staff was held normal to the line of sight. So this is the first time they have set such a question. I know some of you may have done this question normally, but you did not check. So if the staff was held normal to the line of sight, so that is the most important thing that I want us to tackle today. So this error was noticed by one of our online learners, so thank you for that. So the staff was held normal to the line of sight. The other cases, the staff is held vertical to the line of sight. So today we are going to tackle this question that was done on the knec 2023 series, the July series 2023. So let's tackle this question. So this was the second question of tachometer. So the first question I have already tackled it. You need to look at it. So this question, two of the same. So figure 1 shows a right angle triangle RST tachometer fitted with analytic lens, and the staff was held normal to the line of sight. So you remember that the staff was held normal to the line of sight. Was used to determine the following data that is in table 1. So here we have the instrument stations R, height of instrument given there's 1.55, the reduced level of R given there as that is 100 meters. And then we have the target stations. We have two target stations, target station S and T. So that is target station S and T that we are going to use here. And then we have the vertical angles of both those stations. So where we have a negative, that is the depreciation, and then we have a positive, there we have an elevation. So make sure you remember that concept. So make sure you remember that. So where we have a negative, that is depression, then where we have a positive, that is an elevation. And then here we have the upper, middle and the lower. So these were not given, so we'll see how to calculate that. So we're only given the mid and the lower for the station S, and also we had been given the upper reading and the lower reading for station T. So they wanted you to calculate those two unknowns. So we will return there and I will show you how I have worked out that question. So the question continues. So this is just an illustration that was shown on the paper of the right angle triangle. So Roman 1, calculate the horizontal length of ST, and then we calculate the reduced levels of S and T, and lastly we calculate the gradients of S and T, a total of 11 marks. So this is a good question for us to tackle and see what we can do there. So let's continue on in this solution. So here's a solution. This is a formula that I got on the test and the textbooks. So this simple formula was gotten from some of the notes that I have in possession here. So let's look. So this is an inclined line of sight with staff normal. So here the staff is held normal to the line of sight. That's something that you should know. So let's go ahead directly to what we are looking for. So this is the diagram. of when the staff is held normal, and the first case the angle of elevation. So here we have the angle of elevation where the staff is held normal. So there the staff is held normal to the line of sight. So the 90 degrees is found where the C is. So this is where the staff is held normal. So you need to calculate D, which is the total distance from here to where we have our point here. Then we need to reduce the distance that remains to be covered in order for us to be exactly parallel to where C is, and this is where the R sine theta comes in. So we have there that R sine theta that we need. So where we have the elevation, there we add that angle. So that angle is what we are looking for, that is the extra angle to where our D is reaching. So where our D is reaching, we need to add that extra. So in this diagram, the D should be here. They have illustrated that wrongly. So D is the distance from O to where my cursor is. So this is the distance D. Then you add the remaining, which is R sine theta. So R, that is the mid, that is the middle reading found there. So this is the distance that was added here, and our formula, the simple formula. So for a telescopic fitted with analytic lens where C is equals to 0, our formula becomes D is equals to K S cos theta plus R sine theta. Then our V becomes Ks sine theta. Then calculation of the reduced level, you remember on the last part, to minus R cos theta found here. So that is the distance from C to where R reaches at the bottom of the staff. So that is the like the hypotenuse of that right angle triangle found there. So you subtract R cos theta. Other illustrations where the staff is held vertical, we only subtract the mid distance directly. Then we move on to where the angle of depression is held here. So so the distance D is covered until there. So that's where our distance D is covered by adding that. So in order for us to get the horizontal distance that was used there, we subtract R cos R sine. So it's R sine theta. So remember, these are the formulas that we are using. So that extra distance there is what we are subtracting from the information that we have. So here the angle of depression with inclined line of sight held normal to the line of stuff there. So you remember that is an important aspect for you to remember. Yeah, so make sure you remember that. So this diagram has not illustrated it well, but our distance D goes until where our C reaches. So D is the distance to the center of the staff that was held. So that is the reason why we are subtracting the distance here. So our D is the distance moved to where the center of C is, and the same for where the angle of elevation was held. So our D is from here to where our center of the staff C, where our middle distance is read. So that is the where our this is called the crosshair, where our center crosshair is. So there is where our D reaches. That's where in this question we are adding in order for us to have that complete distance there, and here we are subtracting in order for us to have the distance that is supposed to be. So this d that has been written, so the original d, yeah, where the distance, so our distance is from here to here, so this d is the distance that you get after subtracting. So this is the d, but the horizontal distance, the original, was supposed to reach there. So make sure you remember that. Going back to the question, I hope that you have gotten. So here we have ks cos theta plus I will have changed there the sign, so this is h sine theta. This is the formula for where we have the elevation, then where we have the depression, we have to change this sign here to subtraction. So remember that is the another important thing. So before doing that, so first of all, k, this 100, s that is a stadia interval, so that is the interval of a to b, that is the upper reading and the lower reading, the difference in the two. So that's what we need to calculate first. So here we have s. In our question earlier we had not been given those two values, so we are only given the middle and the lower. So the difference between these two will give me, so when you draw the 3 crosshairs, so the distance between the mid and the lower, that because this is a fixed hair tachometer, so this deviation there, the difference between that two is also the difference between the middle and the upper. So when you get the distance that is supposed to be here, that is the distance that you will add on the middle in order for you to get the upper distance, and the same is done. So here we have been given the upper and the lower, so we need to calculate the mid distance. So by subtracting both, so the distance from here to here and dividing it by 2, you'll know where our s over 2 is, and that is the distance that you'll either subtract from the upper or add from the below in order for you to get the mid distance. So that is what I've illustrated here in calculating the two s's. So that is the simplest solution in which you can tackle there. So by doing that, by the use of a calculator, make sure you do it correctly. So let's calculate. So d2, that is the distance from r to s and r to t. So that is the distance that we have here, so from r to s and r to t. So here we have the elevation, then here we have the angle of depression. So by the viewing from the tachometer that was fitted here, and the staff was held normal to the line of sight. That means the line of sight and the staff, there is a 90 degrees there. That 90 degrees is found in the middle, in the mid distance calculated there. So by doing that, d2, that is the angle of depression. So from r to s, that is the angle of depression as I have illustrated it here. Use that formula where we change this sign to be a subtraction. So that is 100 multiplied by s cos 4 degrees 30 minutes minus 3, this is the h or the r, that is the mid reading, and then cos 4 degrees 30 seconds, getting our d as 85.5 meters. So our d1, that is the distance from R to T, so that is the angle of elevation. So R to T found there. So our formula, as stated from what we had seen earlier. So here we have ks cos theta plus h sin theta. So 100 multiplied by 0.41 cos 2 degrees 20 minutes plus the h or the r, that is the mid distance, the mid reading the then sine to 20 degrees, getting our answer as 41.12 meters. So having gotten those two, the d1 and the d2, those are the horizontal distance, we go directly to calculate what the question had asked us. So the distance st, that is the distance between those points there, so s to t, and we were told here in our question, so we had the right angle of RST. Then on the question we were illustrated that, so RST, so there we had our right angle triangle. So by the use of so I have gotten the distance RT and RS. So this distance squared plus this distance squared, the square root of it will give me the hypotenuse. So this means the C also, so it will give me the hypotenuse of the same. So we have such a formula. I hope you can remember it. So this is the formula that I have used in order to illustrate what I've done here. So the square root of both, so we square both those distances and we find our square root, and the square root gives us the distance of S to T. Simple like that. Having finished that, we go, so let us calculate the reduced level of S and T asked there. So the reduced level of S and T, in order for us, so we had been given the reduced level of R by the use of the formulas, and also by the use of this illustration. So here, moving from the bottom of the tachometer, the instrument, so we add the height of instrument, and by adding the height of instrument we'll have found the line of collimation that was held there. So by adding that, we get the line of collimation of both the 2 points. So they had a constant, so the line of collimation was the same. So the line of collimation goes to this distance. So our V is from the line of collimation to where our mid reading was taken to, then our mid reading to the bottom of the staff, and that's how you get the reduced level of S. Then again, by adding the reduced level of the instrument plus the height of instrument, we get the line of collimation here. Then our distance V, that is the distance from the line of collimation or the line of sight to where our mid reading was taken to, then our mid reading, that is H, until we have the bottom of the staff. So in order for us to get all this value, you will need to move to the line of sight, and then you subtract the V and you subtract the H, that is for S. Then here again we move the line of staff, we add the V reaching the mid distance, and then we subtract the mid distance in order for us to get the reduced level of T found on the bottom of the staff. So remember that is the important thing that you need to do there. So by calculating our vertical distances, the formula was simplified just like this. So the vertical distance 1 and 2, and you get both your answers. So these are the V's that I'm going to be using in order for us to calculate the reduced level of S and T. So by calculating those V's, we move here. So this is the reduced levels of S. So we have added the reduced level of our point here, our point R, and by adding that to the height of instrument to get the line of collimation, then we subtract the V and we subtract now the formula. So here it's H cos theta. So this H cos theta replaced the H that we had previously in all our calculations of the vertical, and the stuff being held vertical to the line of sight. So this is where our replacing mainly is, and that is found in both our text. So these are the formulas that we are using. So the reduced level of the stations, this station that was given here, plus the instrument plus, so but I think you get the concept there. So we are only changing here because this stuff was not straight. So that means in order for us to get the right data, we need to find this distance here, and that's where our R cos theta comes in. So that is the distance that is replacing the R found on the stuff that was held normal to the line of sight. Remember, that is an important thing that you need to remember. So that's where we are replacing that. And then the reduced level of T, we had the reduced level of R added by the height of instrument, getting the line of collimation. Then here we add the V, and by adding the V we reach the stuff where our mid distance was. Then we subtract our H cos theta of that position, getting our reduced levels for S and T. Having done that, the last question is calculating the gradient. So the gradient, that is the distance, the gradient. So we use the reduced levels, so the distance between those two reduced level found on the y and the x axis. So on both these two axes, that's how we calculate the gradient. So the distance here is 0 to 94.87. so that is the distance there. So by subtracting that, it remains the same. Then the interval between these two, so the interval between these two, this distance from here to here, that is the interval between those two, that will give you the distance that is found on the upper part of the calculation. So by simplification of that, our gradient becomes 1 into 12. That is the gradient, 1 into 12, or 1 in 12. So that solution was that simple. Remember that. So this question, they have that trick there. So this is the stuff held normal to the line of sight that we were using. So more lesson found on the channel. Make sure you go and you see the questions. Thank you. That will be all for today.